Hello everyone, my name is Håkon and today I'll present our paper DeepPrivacy2 towards realistic full-body anonymization. The video you're seeing here demonstrates results from our proposed method, which anonymizes the full body by replacing it with a synthesized identity. The main motivation for our work is collecting images for computer vision development, where anonymization is required to comply with regulations in many regions. For example, following the GDPR in the European Union. Traditional image anonymization degrades the quality of the data, often making it unusable for computer vision development. Instead, realistic image anonymization can retain the image quality while preserving privacy. Previous work has focused on face anonymization, however, this often leaves the full body recognizable through other means than the face. In this paper, we focus on the full-body anonymization task. In the wild, full-body synthesis is a very challenging and underexplored task. Previous work has focused on simpler tasks, such as training on structured datasets, transferring garments, or changing the pose or motion of an individual. The majority of these methods disregard the background, which significantly simplifies the task. This makes these methods inadequate for in-the-wild anonymization. Our previous work on full-body anonymization explored training a GAN conditioned on dense pose on a subset of the COCO dataset. A major limitation of this method was the dataset, where we noticed that the discriminator overfitted early in training, resulting in severe artifacts in the generated images. In this paper, we focus on this main limitation. Our main contribution is the FDH dataset, which removes the issue of overfitting. The FDH dataset consists of 1.8 million annotated images of human bodies, where each image is annotated with a mask indicating the human body, 17 key points, and a dense pose annotation mapping pixels to vertices on a 3D human body. The FDH dataset represents many of the challenges of in-the-wild anonymization, such as occlusion, difficult viewpoints, overlapping bodies, and partial bodies. Combining this dataset with a fairly straightforward GAN, we are able to generate close to photorealistic images. These are some of the synthesized results from our method. Notice that our GAN perfectly handles the background and is able to handle challenging cases. For example, if you look at the man holding a guitar, our method completes the partially segmented guitar. Or, if you look in the upper right image with a man running and focus on the boy in the foreground, you might notice our method completes his segmented arm even though he's not the subject. Here you can see some results of in-the-wild image anonymization. Notice that our method handles overlapping bodies and generates a diverse set of identities. We recommend you to take a look at our paper for more examples, where we evaluate on both the COCO and Cityscapes dataset. Finally, we train our GAN for face anonymization and release a new dataset for higher resolution face anonymization. In comparison to previous methods, our GAN generates higher resolution without relying on keypoint annotation, which is often used by previous methods. In addition, as our GAN is based on StyleGAN, we show that our faces are easily editable based on text prompts by using StyleMC with Clip. If you want to find out more, please check out our open source code or come by our poster. Thank you for your attention.